All right. Welcome everyone for today's session on the green energy. Let me know if you can see my slides. You can write in the chat plus. We'll be using today chat for feedback so I can see if the quality is fine. So yes, all right. Let me introduce myself for those who don't know me yet, or for future students who will be watching this online. My name is Ekaterina Markelova. I'm a double PhD in Earth, Environment and Universe from the University of Grenoble in France and University of Waterloo in Canada. And I'm a professor, adjunct professor at the EADA Business School and a professor at Samara Aerospace University. I'm an expert on water technologies, green technologies, how to use water more efficiently, and how avoid using harmful chemical substances to treat water. So we are looking not only into how to improve the energy sector as efficiency, but also most importantly, its environmental impact. This is my role at the Nanoresonance Industries company. And soon we will be opening the Nanoresonance Institute. So today's lecture, Green Energy, is a brief extract from the potentially full extended program on the green energy. And hopefully it will be available already next semester. All right, so before we start, I would like to ask in the chat, any name that you think relates to green energy, like sustainable energy. You can write all of them. What comes to your mind? Eco-friendly, zero carbon, or whatever, like all this terminology that is being used nowadays. And sometimes it's used interchangeably, and sometimes we don't even realize what it means. Renewable, hydropower. Biofuel. And especially focus on those words that are less defined. What is green? Like green energy, is it sustainable, renewable? Yeah, electricity from waves, wind energy. So I see what comes to our mind is the source of energy, like wind energy or biofuel, and also the types of like renewable, right? So today, my goal is briefly to introduce you to these concepts. What is behind them? And of course, one class is not enough for such a big topic, but at least I would like to set the base and to set you as some indicators or quality questions that you can ask yourself when you're performing the project. Is it answering my goal? Is it my goal the eco-friendly technology? Is it green? Is it sustainable? Or is it all of this? Since all of you have different background, today's lecture is really introductory. For some of you, it will be repetitive moments, but for me, it was important to set the framework. So I hope this will be useful for you. And I see that someone wrote nuclear energy, which is one of my favorites. So I'm very happy that it comes to your mind because today we will also see some of the examples. And it's really great that you mentioned nuclear because normally students don't consider nuclear as a step for decarbonization, but in most of the countries like Russia or France, this is one of the major strategies to achieve decarbonization. All right, so today we will speak about the roadmap for energy transition towards green energy, sustainable energy. We will dig into the question, what do we mean by saying green or sustainable? What do we want? What is our goal and how we are trying to achieve it? And then to answer those questions that I will place, I will briefly introduce you to some of the green technologies and life cycle assessment results. Of course, due to time frame of this class, it's impossible to look into the all technologies, so we will just focus on the wind turbines. But you will see analogy how you can analyze or estimate at least the impact of other types of renewables. And by the end, we will have time for Q&A. So you can also write questions in the chat. I hope I will see them. If not, collect the questions and we will have time by the end of the class. All right, so let's start with the roadmap. And as you most likely already know, these laws and regulations, of course, they're not limited to this list, but some of the most important regulations that control the energy transition. European Green Deal sets the net zero industry transition by 2050, Renewable Energy Directive that is ambitious to set the goal to 42% by 2030, and also has an ambition even to raise the plan up to 45% of renewable. That's why it's very relevant to understand what is renewable. Then the Energy Efficiency Directive that is setting the target to actually not only depending on what type of fuel but how do we use it, right? So how efficiently, what is the capacity, what is the energy losses? So ideally, we can improve our technologies, and the target is to improve almost by 12% by 2030 compared to 2020. And of course, European Commission's energy roadmap that is highlighting that we would like to reduce greenhouse gas emissions up to 95% compared to industrial levels, pre-industrial, and that this is possible by the energy mix. They're not saying that only one type of energy is possible to replace all the carbon emitters that we have right now, but they highlight that the energy mix is most reliable and most sustainable solution to achieve these ambitious targets. So by summarizing the major regulations, I have made this short list, which will be a little bit larger at the next parts, but basically they're speaking about low carbon energy, and this we know that we can calculate by carbon footprint. They speak about energy security, so it should be sustainable energy sources that are reliable. Affordability is about the price and cost, of course, and environmental sustainability. And here it is normally discussed in the frame of renewability, right? But also, as we will see later, environmental sustainability could be much more complex rather than the source, as it is renewable or not. So in the energy mix, it is desired that the renewable energy will be up to 35%, with the nuclear energy 22%, and the rest would be the fossil energy. Well, this was by 2018, and this is gonna shift towards the target years. But as you see here, nuclear energy was distinguished from the renewable energy. Nevertheless, it's accounted for low carbon energy. So here it comes that the nuclear energy becomes competitive in terms of the targets of decarbonization. And if you look into the graph of the energy mix, of course, it uses the models to predict how would it evolve over time by 2050. And we see that by 2050, the goal is that 66% of electricity will be no carbon or low carbon emitters, with 40% of renewables and 26% nuclear. And also the effort is planned to be put on carbon capture systems. So even though some coal plants will be still operating by 2050, it is assumed that they will be updated by these systems to decrease the carbon dioxide that is emitted into the atmosphere. And here on the graph, we see already net generation capacity, which is also interesting to take into account because in order to run the power plant, we also need the electricity. And what is most important is the net, is the electricity that is left after it has been generated minus the electricity that actually required to run the power plant itself. So what we can see here by the light pink, you can see the wind power that is in one of the scenarios is planned to be really increased drastically. So the solar is also planned to be increased, while the hydro is remains more or less the same, and the nuclear energy also remains more or less the same. So, of course, there are different scenarios. This is an average scenario of many of them, but we see the main idea behind what is planned. So the roadmap document actually has these scenarios and offered us 5 scenarios, either to increase the efficiency of technologies that we already have, which I think it shouldn't be either. It should be by default. First of all, we optimize what we already have. And then the other scenario is to open market for competition. And I would say for our company, as for technological entrepreneurs, it's very important. It's really hard to enter the market that is quite closed. So this is really important to support the new innovative technologies become open market competition. The other scenario is the effort into the high renewable sector. As we've seen on the previous graph, is the major effort is on the wind turbines and the solars. The fourth is the focus on the carbon capture and storage technologies, which are still innovative, and they're lacking the some of the proof of the concepts. So it's still an ongoing process to figure out how it can be sustainable and profitable. And the final scenario is the low nuclear. It's considering that nuclear will be taking less part in the transition. So different scenarios are possible, and as well as possible a mixture of them. And this is the also model that predicts the distribution of energy production by different scenarios. And as you can see by light blue color, it's renewables in any scenario, they are going to increase as compared to 2005. And while the use of oil, which is dark red, will reduced. The natural gas, which is green, will be kept, I would say, at large portion. And it's interesting to see that nuclear, which is the pink, in the scenarios 1, 2, and 4, plays a significant role, which for me makes a lot of sense, and I'm really happy to see it because myself, I've been working for environmental consultancy for nuclear waste disposal. And this company is located here in Barcelona, and we had clients all over the world. And that time, it was already 7 years ago, the nuclear was not under much discussion as an energy transition. So nowadays, I'm really happy to see that it takes its part in the energy mix for sustainable energy. Anyway, no matter what is the plan is or scenario will be chosen or how it is going to be implemented, the major goal of the European Commission's energy roadmap is to decrease the carbon footprint by at least 75%. And the major drivers would be to lower the emission trading system cap while increasing the prices to carbon. This is not my favorite part, honestly, because I believe that technology can play a big role into this transition, and that other drivers can play also significant roles. These are more political and economic drivers, which already take place, and we see the carbon market is expanding very rapidly. But here I would like to focus that the major goal is still about carbon market. It's not about the holistic environmental approach that is actually desired for what we would like to call renewable and sustainable. So here it comes. What does it mean? Renewable, green, sustainable? Because sometimes, especially in the news, it's been used in a various ways. And for you, I would like to showcase these 5 top criteria that I identified based on the different regulatory documents. That what is sustainable energy? It's actually beyond just renewable or just green energy. To my experience and understanding, it's first of the goals is low carbon energy. And again, we can calculate carbon footprint and set our strategy to decrease it. But it's also environmental sustainability, which is can be calculated by a life cycle assessment. And we know that in life cycle assessment, instead of one environmental footprint, carbon, there are 13. And taxonomy document, European taxonomy, is already recognizing this, that beyond carbon, we need also to look into the water footprint and biodiversity as minimum. So here we are talking about looking at the energy source sustainably from the holistic environmental approach. The third criteria is source renewability, is normally what is spoken about when we speak about renewable energy sources, right? We will take a look what it means, the source, but all of you know, either we are using fuels, right, that are limited sources, or we are using the flows. And the flows could be flow of wind, flow of water, or flow of sun. And normally it's considered renewable, but what we can see under changing climate conditions, it's not always sustainable. So we can also think in the context of our reality. And the fourth criteria is high energy security and efficiency. That's exactly about it. It's how sustainable is energy production, because when we are entering the era of climate change and we are actually creating the solutions to mitigate the climate change, so ideally they should withhold the climate change itself, and we will see if it is possible. And the last criteria is affordability and sustainable investment. Affordability for us, for users, and also for companies to develop this market. So this is, I would say, a quite complete criteria list that I would like you to remember as a major takeaway from today's lecture. That when you consider investment or sustainable projects, or for example, recommendations for the companies, how they can decrease their carbon footprint or total environmental footprint, to consider the potential investment through all of these criteria. Looking at the capital cost, I found this graph that represents the basically capital cost in euros per kilowatt energy per hour as of 2010. And this you can see for each type of energy production, we have 3 blue colors. The dark blue is the model that calculates based on the price-induced market equilibrium system. The other blue is International Energy Agency data, and the light blue is from US Energy Information Administration, from Department of Energy. I see the question in the chat, and we will discuss about it in the next slides. Let me know by the end of the lecture if your question will still be open or not, because this is coming. So what we can see in this slide is at least for it is considered energy for coal, and we can see the different coal types, either with carbon capture or not. Carbon capture, you can see, is the most expensive, right? So it adds additional cost, of course, to the power coal operation. With respect to natural gas, you can also see once the carbon capture is added, the price is almost twice higher. Nuclear is always considered quite heavy on the capital costs, but surprisingly that if we compare nuclear to, for example, wind that is offshore, that is a very comparable price. Or if we consider the solar that is thermal, which is also called concentrated, or if we consider the large photovoltaics or even sometimes small, so the nuclear surprisingly becomes competitive. And this is explained by the fact that if we look into the full life cycle of the power plant production and also the kilowatt hour generated over the plant's lifetime. And as you know, the nuclear, it has quite longer lifetime than the solar panels, let's say, or wind turbines. Over full cycle, it gets comparable. So this graph for me was really highlighting the message that nuclear is really one of the good energy sources for the energy mix transition. And if we speak about investments, normally what is considered nowadays that innovations requires investment, but it's okay because we save environment. So this is the largest investment loss, unfortunately, that Siemens company, its energy daughter company that was working with the Gamesa, they declared quite large losses because of the malfunction of their turbines. There were technical issues that caused these losses. I see the question in the chat. Let's collect those questions by the end of the class, all right? Because the lecture is actually not that big, and I can talk a lot on each of these parts. So yeah, I think if it's not immediate question, please keep it till the end. I mean, immediate if something is not clear on the graph. And someone has sound. Okay, I found it. So for this case, I guess some of you have heard about this case, and maybe in the chat you can write plus if you have heard and minus if you haven't. So I see that none of you have heard about this case, which is quite a significant case because they speak about the losses up to 4.5 billion euros for 1 year, while the net profit of entire Siemens Energy is 1 billion a year. So it is tremendous investment loss that the CEO said that it was too early to invest into the such a new product. And Siemens has, of course, high reputation, so that in overall, they were able to save their reputation, but in general, the quality of technologies is now very questionable because the problems were in the rotor blades and also some main bearings across the platforms. And to replace and to improve the quality of this technology that would require even higher investment. And when they said stop, we have to re-evaluate our investment strategy. And for now, they didn't, as far as I know, they didn't announce the new strategy, but they were shocked that it's actually significantly worse than previously was expected. So there are some also other issues with the weather patterns. And a year ago, there was a massive hurricane, which was with the hail, and it destroyed the solar panel farm that was very new. So it was just built in July 2020, and after 1.5 years, it was damaged by the hailstorm. And obviously, the investment also didn't work out in this case. And even more, the environmentalists, they were concerned that there could be some heavy metals that are toxic. And that's why some of the solar waste is considered hazardous because of the metals inside. But it also has to be stressed that there is no common recipe or technology for solar panels. It depends on the type, on the model, and on the company who is producing. So it's good that this model of the solars, they didn't have cadmium telluride, and so that it was identified that there is no risk to the community or environment. But otherwise, sometimes indeed, there are heavy metals that are quite toxic. And if the solar panels the waste from the solar panels is not taken care as a hazardous, it may cause additional environmental concerns. So about this hail also storm, could you write now 1 if you have heard about it and 0 if you haven't? Okay. I see that none of you have heard about it. And this is the reason why I'm asking this is because media plays a very significant role in what we think is sustainable and what is not. And coming back to the question about nuclear, if I can speak about its safety and so forth, media also plays a big role in that. And for example, about these wind turbines and solar panels, most of the media is selectively choosing only pros, while cons are not discussed, which is not very sustainable, I would say, because to be honest, we have to consider all the factors and then to remember the goal, why we are doing that. So to consider the other criteria, I would invite you to look into the green technology, what it basically means, how the energy is generated, right? On the right corner, on the top, you can see that power plants generate electricity by rotating generator. And I hope after today's lecture, you will simply understand how all of these technologies work for the level enough to understand where to pay attention. So all of us, we want electricity, right? And electricity is a type of energy. And basically what we use, our different technologies, is to convert energy. And originally, this energy, most of the time, when we are using the fuel, is chemical energy. For example, fossil fuel, such as coal, right? So you can imagine the coal that is black coal, for example, and what is made is carbon, right? Or the biogas is methane, it's carbon. Biomass is also carbohydrates. So it is something that a lot of energy is stored in carbon. That's why, like people, we eat vegetables or we eat food because we need carbon to make our body work. So a lot of chemical energy is stored in carbon bonds. And in order to extract it, we created all sorts of varieties of energy technologies, how to extract the energy from the chemical bond from small molecule and to run our computers using the electricity. In the nuclear, the energy is different. It's not carbon, it's the fission energy. And most of the time, it's some kinds of uranium or plutonium energy. So if you think of the molecular level, instead of carbon, it's uranium. And yeah, it's a different types, but it's also stored and it's not that easy to extract it. That's why also coming to the question about safety of nuclear, sometimes there is a threat that, for example, nuclear waste storage can be bombarded and it would cause the explosion. It's not easy to extract explosive energy from the bonding. So it's really, we create entire nuclear power plant to drive this energy conversion. And the solar energy, you may be surprised that I put it along with this because it says fuel. Because we have different solar energy types. And I think most of you know the solar panels, but maybe not that known is concentrated solar power. That is very different from the photovoltaics. This is a completely new way of solars that are just mirrors. So it's completely different type of technology that has only the same word solar. But in this case, the energy of solar energy is used. And why I put these groups of energy generation in one, because the goal is all the same. We have some energy that we would like to convert, and you would be surprised, but we need the energy carrier. And well, let me ask you before I tell you, what do you think is energy carrier in our body, let's say? So, for example, when we eat food, we have to carry it to distribute it. Fat, it could be good, but I think it's more storage than the carrier. Other ideas? Mitochondria, wow, that's profound. That's energy station, right? Veins, oh, good. Yeah, blood, very good. Well, of course, all of this could be right. It depends on the context, but what I tried to navigate you to is to our flow system. It could be blood, it could be lymphatic system, it could be any kind of water-based system, because both lymphatic and blood systems, so they can be carriers that actually takes the carbon and brings it to the cell, that brings it to the mitochondria to actually create the energy. But if we think what actually helps to travel, it's the energy, or it's the water. And water has the incredible capacity of carrying the energy. It's actually by now has the highest energy capacity and heat capacity. That's why it's used, you would be surprised, but in all of this energy generation. So the water footprint is the second that we need to think about when we think about energy production. All of these energy types, they burn either chemical like fuel, or they create the fission energy or solar energy. What they want is to boil the water, because once they can create this thermal energy and the water is boiling, water has thermodynamic properties to change its phase from liquid boiling to vapor. And when it happens, it also changes the type of energy. From thermal energy, it converts to kinetic energy. And what it means kinetic is basically moving energy. And vapor, it has such a strong kinetic energy, the strongest, that it's actually enough to rotate the turbine. So it creates the mechanical energy. And the mechanical energy of turbine is then converted to generator, which is finally creating the electrical energy. So all of the efforts are made to make the turbine rotate. And so far, the best rotator is our vapor. And so all of these energies have in common the fact that they create thermal energy to convert liquid water to vapor and then to rotate the turbine and rotate the generator. And the question about solar also needs water. Yes, it depends what kind of solar. As I just mentioned, that a solar is just one name that means very different technologies. And here in the brackets, you can see concentrated solar power, CSP. So this is less known, but you have to know about it because it's very different from the photovoltaics. What it does, it has mirrors, not panels. Well, it looks like panels. So if you don't know, if you're not an expert, they look like mirrors. But what they do is actually they reflect the sunlight and send it as a lens to the water bucket. It could be either one water bucket and then they point the solar energy there, so the water is boiling there. Or it could be the pipe attached to these mirrors and the water is boiling inside of the pipe. So yes, the concentrated solar panels, they're also called thermal solar power. They require water. That's the way how they operate. And that's a large manufacture infrastructure for this kind of solar. So thank you for asking because this is very tricky. When I read lectures, I noticed that students are not very familiar with these concentrated solar panels, but this is what is mentioned in all of the regulatory documents. So it's important to understand that they also use water. And actually, I think I have this slide. The water use is as big as for nuclear power plants. Excellent question. If these require blue water or can they use gray water? Well, right now, I don't know if some of them use gray water, but ideally it should be like that because blue water is the fresh water that of drinking quality. And for such large operations, it should be less graded quality of water. And actually, in most of the systems, they recirculate the water. So it becomes gray water because it's a technical water, but purified. And what is interesting, actually, in the, for example, nuclear power plants, normally we think of the large water towers that have steam going out of them. And where to take such large amounts of water for such big towers and nuclear power plants? Normally, they're located by lakes or the rivers, and they take the river lake or river water to run through the cooling system and dispose it back to the river. So it turned out I was doing my diploma thesis on the one of the nuclear power plants, taking the water from the River Don, and I was looking how it impacts the water quality. And it turned out that actually it cleans the water because river water quality is worse than technical quality that is required to operate the cooling system. So actually, by taking the water from the river, water nuclear power plant first treats it, it filtrates it, and then using it for cooling system, and then releases back. And the only adverse effect that it has is increased temperature. And the temperature is normally hotter. So some of the nuclear power plants, they discharge the water that is in the close proximity, that is up to 10 degrees Celsius higher than the average water if it is a large lake, and they use it for fish farming. So there are different solutions how to use this warmer water. But the quality of water itself is better because for the technical use, it needs a higher quality than in the river itself. All right, so surprisingly, I hope now it's clear that whatever the source of fuel we use, we end up with using water and converting energy through these brilliant properties of water that can change the phases, that after all can rotate the mechanical turbines and create electrical energy through generators. And I see the question, if the increased water temperature make an impact on wildlife. Yes, it does. And there are different measures how to decrease this impact. And sometimes it boosts the growth. And for example, as I mentioned, for the fish farming, it's used as a good. So they grow faster fish. But for other occasions, it could be bad because it may enhance the algae grow, which can create the algae bloom and eutrophication. So this is the concern. And when it happens, it leads to decrease of oxygen in the water, which can cause the lack of oxygen and death of fish. There are different problems with heated water, and there are different systems. For example, sprinklers. For example, they discharge not through one pipe, but through the system of sprinkles. So by the time the water fall, it already cooled down. And also the scale of the impact is also regulated. So it's not that entire lake is being warmed up, but it's a close proximity up to 100 to 100 meters, depending on the depth of the river or the lake to the power plant. So it's no one problem. And I know that different systems are being used to decrease the difference in this temperature. What about the other plants? Solar, biomass, they just throw away the water or also put it back into the rivers? Well, solar, if it is concentrated solar power that I told you, they try to recycle it. So it's actually a good system that there is no reservoir needed normally, but they try to recirculate this water. And for the biomass, well, for biomass specifically, I don't know. I don't know. So in these types of energies, when we create the energy through wind or hydro or solar, we can call them flow-based energies. It means that they don't use like fuel, like we talked before, but they use flow of wind energy. And the idea is the same, is that the difference is only that we don't need a carrier like the water to convert the energy, but the flow itself can rotate the turbines. The entire idea of creating the energy is basically creating the rotation of the turbines. So at this step, we don't need carrier, we don't need water, which means directly can create this energy to mechanical energy. And the energy of flowing water, even though it's water, it's flowing, so it's a different concept. Yes, water is used here, but it's considered renewable because it is from rivers. My only comment here is that the energy of flowing water, and when the large hydropower put large dams, actually the flow is reduced. So it's also very case specific when the hydropower can be considered renewable or sustainable. So by this moment, only the small and derivative hydropower is considered to be sustainable, while the large hydropower is causing the degradation of the rivers, which actually stops the natural flow of water. So this is also very specific to the scale. And the solar energy that is using photovoltaics is a different type of energy that is converting the solar energy into the electrochemical energy. So when we speak about renewability, in a short term question, or how to say, in a simple question, we can ask renewability of what? When we speak about the resources, it's clear. Renewable source energies like wind considered renewable, solar considered to be renewable. But the technologies that we are using to produce energy, they're not renewable. So I like the saying wind energy is renewable, but wind turbines are not. And brings the bigger concept of the life cycle assessment. So when we think not only at the production phase, the production of energy, but also the construction and disposal, it brings bigger perspectives. And for example, the metals that are used in wind turbines, they can be, again, either toxic or they can be actually critical raw materials for European economy. And on the left, you can see some metals that are actually toxic, like copper, nickel, zinc, and chromium. And that's why it's also a concern for waste disposal. And if this is not taken responsibly, then it can leach these metals into the environment. And the rare earth elements by themselves, they are not considered toxic normally, but the major problem with them is that they are strategically important. And Europe, we just don't have the mining of rare earth elements. So it's a geopolitical issue when the renewable energy actually relies on the export or import of the metals from China and from South America. So this is another concern that brings a bigger picture to consider that even though the source can be renewable, the way how we create it, it's not. If we look into the environmental impact beyond the carbon footprint and do life cycle assessment, as was performed by the United Nations Economic Commission for Europe, in 2020 for wind onshore, it says that basically what it considered 8 factors. One of them is minerals and metals. Second one is dissipated water, then land use, ionizing radiation, carcinogenic effects, freshwater eutrophication, and climate change total. So when they speak about climate change total, it means carbon dioxide equivalents. I believe this is most familiar for you as a carbon footprint, but also all the other greenhouse gases that are called equivalents. And in the chat, please write plus if you have heard at least like about these environmental factors discussed in the context of renewable energy or sustainable energy. And write minus if you have heard only about carbon footprint or climate change. Okay, I see a lot of pluses, so it's good. Because I think it is changing over the last 10 years. When I just started working on this topic, carbon footprint was the only factor that was considered. And nowadays, as European taxonomy brings it up to the water and to biodiversity, and even larger is the life cycle assessment brings at least these categories. That is actually provides a very full spectrum image on what is going on and what life cycle stage is the most causing environmental impact. And out of this, we can say that 95% of environmental impact comes from construction and assembly, which is not very obvious when we speak about environmental impact or renewability. And this renewability implies that it's eco-friendly technology. The operation and maintenance, surprisingly, they have impact on ionizing radiation, climate change, and the land. And this is not very obvious, but I would like also to show you some of the examples of hydro turbines, why they're considered to have impact on land. Well, they can break, right? And they're actually made for high wind speed. And why they are so tall? Because the higher the tower, the higher the speed of the wind. So it's easy. But also it means that it's susceptible to breakages under extreme wind. It may also corrode under rain, fog, or if it is close to the sea or on the sea water. Most importantly, it can spill the oil or diesel that is used to actually run the turbines. So it's estimated that turbine contain up to almost 1 ton of oil or hydraulic fluids or lubricants. And these oils, they have to be high purity, which means it's expensive for operation. And sometimes when you travel by car or by train, you notice on the fields, some of the wind turbines, they're not working. Yeah, I think sometimes you see some of them rotating, some of them not. And the reason why they're not rotating, because it's quite expensive to operate them. So most of the time, it's most economically viable not to run them. And sometimes, unfortunately, the leaks happen, and this can contain contaminates farmlands and forests. And if it is close to the rivers, it may migrate to the groundwater or the surface water and spread through the environment. So this some contamination that is hard to track. And I know that right now there are innovative systems that are built like indicators inside of the turbines to actually detect the oil spill. So I know that the measures are being taken, but it's also something to keep in mind, something that could be risky when we choose the location for the wind turbines. Like how close is the groundwater, let's say? What is the depth of this? How close it to the surface? So this has to be taken into consideration. And there are some innovations in the wind power. And the other take-home message from today's lecture I would like you to have is please avoid generalizations of what is like green energy, renewable energy, or even solar or even wind power, because they are classified by groups, but there are so many different types. And for example, these types, they are also considered wind, but they don't require the oil, for example, for maintenance. Or, for example, this kind of laminar and magnetic turbines. And when I was last year in Salamanca at the PCT World Congress, I met this scientist who invented the new types of wind turbines. And even though it's the same category of wind energy, it's a very different technology. So they don't use oil, they don't produce noise, they have a very small surface area because they have high capacity to generate electricity. They resistant to hazards, so they were tested under extreme conditions, even in like in wind blizzards. And we can even say that there are no touching parts, so they are kind of lifted based on the laminar flow. It means that there will be less maintenance. They can be placed on the roofs, and one such turbine will be enough, for example, for entire high school. So there are different technologies that exist. And yeah, this is the wind turbines that were even tested in the Iceland. And normally the wind conditions are so strong that normal wind turbines are impossible to place there. And with wind turbines is also curious because we would think that the more wind, the better, but actually they have a quite narrow range of the wind speed when they can be efficient. So when it's too slow wind, we have to shut down them because it's inefficient to run as a maintenance cost. When it's too high speed, again, we have to shut down them to avoid the breakage. So this kind of wind turbines, they have shown to withstand the hazard of the wind of the 85 rotation per hour. They also use eco-design, so they're not made of metal, but they're plant-based. It is a composite material. So it's a special chemical formula that are mixed with catalysts, and they create the blend of resin. And it can get any shape because it is made in the vacuum chamber. So it's very soft until it gets into the vacuum. And since it's not metallic, it is not corrosive. And since it's not metallic, it's very lightweight. And it's funny that it can be colored in any color or pattern that can be blended with environment or any infrastructure that we want. And these are some the prototypes of the different colors that if you see, you would never guess that these are wind turbines. And of course, these are not real. These are prototypes that he used for the conference. But it's idea how the larger turbines can be blended, for example, in the forest, or which is also important because when we think of the footprint on the land, we see a big destruction of the change of the landscape. So this can also be helpful. So some takeaways from the wind power is that there is environmental impact behind just creation the energy, and most of it comes to the construction of the wind towers and the foundations. There are some minerals and metals that are needed that could be toxic, or they could be critically critical for Europe, for economic and for safety of European economy. There is if we consider beyond just the carbon footprint and think that the blades that are made of glass fiber, they contribute to climate change 16%, while they change the water impact by 27%. So sometimes the other environmental impact comes more drastic than the carbon footprint. These kind of sources, they need to consider the backup power because they are highly dependent on the weather condition. There are some unexpected spills that could be hazardous and that also can impact the location where we would like to select the place for this. And there are always innovations. So I encourage you to keep your eyes open for new technologies that exist. Maybe they're less popular, but they certainly exist, and hopefully the market will be more open in the near future. Because even for this professor, it's not easy to enter the big market. So I really hope that it will be easier in near future. If we look into the carbon footprint and imply that the sustainable energy or green energy is equal to low carbon energy, we can also use life cycle assessment studies that compare different types of the energy production. And by arrows, you see the basically the different plants. Again, because there are so many types, it's almost impossible to compare solar just between themselves. You see the error bar for the solar is much bigger than the impact itself, because it means a small solar, large solar, and the concentrated solar. And all of these are incomparable based on the how much actually energy they produce. And this graph is normalized per carbon dioxide equivalents per energy produced, per gigawatts per hour. That's why sometimes arrows are higher than the impact itself. And this is just highlights my key message that avoid generalizations. Basically, to conclude, what we can see is even if we generalize, these kind of energies are really known to be low carbon energies, and the nuclear is also one of them. these kind of very complicated results, but that's what we get when we do a very detailed scientific life cycle assessment. And this was also the carbon footprint normalized per energy produced. And basically what we see by the nuclear like the smallest is 4 point, it is in the middle of the graph, nuclear, and it is the minimum value is 4.9 and maximum 6.3, which based on these different countries makes it the first smallest footprint if compared to even small hydropower, wind or solar. And here you can see the difference in solar, which is solar concentrated versus the solar photovoltaics. So the solar concentrated goes right just after the nuclear. It's called CSP. So whenever from now on you see this abbreviation, please remember that it's also solar that is using water for energy production. And as you can see, it has also higher carbon footprint. And the photovoltaics within themselves, it's a large group that comes just before the wind. Here you can see the group of 6 different types, and they could be a small, large, roof, ground, and also the silicon-based design of the panels themselves. So this shows you actually diversification, how many different types exist across different countries. This is the material use assessment that considers not only carbon, but also for example, other materials, steel, some glass or concrete or cement. And this also shows the material carbon footprint. And here again, we can see the smallest footprint. It has nuclear, and then geothermal, then wind, hydro, and solar. Why is it always I show you that nuclear has the smallest? The reason is because this is normalized per electricity produced. And whenever we speak about sustainability, or whenever we speak about the energy transition mix, we have to think normalization per electricity produced, because we know that the population is growing. We know that every year our electricity demand is growing. So it should be not only the environmental friendly technology, but it also has to be feasible based on the electricity production. And when all these accounts taken into consideration, nuclear comes in some studies at the first place. This is another study that extends to material use, also the water use. And the blue color represents the water footprint. And here you can see also distribution, that the smallest footprint is wind, then the solar, nuclear, then concentrated solar panels, and the hydropower. And personally, I try to avoid compares such as like smallest footprint, highest footprint. It's always should be context specific. Where it is located, is it in the desert or in the forest? And to consider what kind of environmental impact is more relevant on the time scale and the spatial scale for this specific environmental or ecosystem, or for this specific social system or culture of people. So carbon footprint is good average, but it doesn't work for all the communities or for all climatic zones. That's why it's really important before investing a large amount of money, for example, to reduce carbon footprint, it's good to perform life cycle assessment to make sure that this technology is actually relevant for these climate conditions and for this ecosystem. And speaking about the ecosystem, here we have many more results from the life cycle assessment. It has ecotoxicity for the fauna that exist on land. It has natural land transformation. And this is easy to understand, for example, for hydropower, when we build the dam, we change the flow, we change the aqueous land. So it also the land change, for example, in the wind turbines or solar panels, right? Sometimes we see farms that are even built on the place of the forest. In Brazil, there is known case study when the forest was cut to place the solar panels. So this is called natural land transformation. What is also considered here? Marine ecotoxicity, freshwater eutrophication. Freshwater eutrophication, as we discussed, it may come from the temperature change, but mainly it's considered from the chemicals like phosphorus or nitrogen. Well, different technology use differently elements, but it's also good to consider potential impacts. Climate change, this is known carbon footprint, agricultural land occupation, and terrestrial acidification. So this is quite extended list of environmental factors that can be very specific to answer what is our initial goal. So is it the goal is to compensate our carbon credit, or we would like to cover our cap, or like enter the carbon market, or we really want to protect the ecosystem that, for example, may have some significant environmental impact from this technology. Well, based on the results, I think it's obvious that the coal has the largest impacts, no matter what factor we consider. Then I would say the natural gas is following it. Here in the hydro, you can see exactly what I meant. Like the large hydropower, that is here is 660 megawatts, has almost 3 times larger impact than the small hydropower. That's why when you hear about hydropower and it says as a renewable energy or green energy or whatever it's claimed, specify, is it small or large? Is it derivative or not? Today, unfortunately, we don't have time to go to all of the types of the energy produced or energy generation. But my goal is to give you key questions that you may ask when you have an opportunity to select what project to support. Then we have nuclear, that is basically also summarized it just in one category. But nuclear has so many types of different reactors. It has different fuels. It produces different quality waste. So it's also, for me, sometimes surprising how it's possible to put all nuclear into one study. Photovoltaics and wind. So I hope these studies gives a bigger perspective on the environmental scope, what can be considered. And here we have, wait a second. This was mainly for the ecosystem health per 1 megawatt per hour. And this is the total environmental footprint. And basically, we see that the picture is changing when we consider even more factors like ozone depletion, when we also add ionizing radiation or human toxicity. For example, if you look at the hydro, you see that the large hydropower is now 10 times more environmental impactful negatively than the small hydropower. So this is always good to ask questions when we compare one impact to another one. How many impact factors have been considered, right? Because the change comes from factor of 3 to 10. And some key takeaways from the these low carbon energies that, to my opinion, life cycle assessment, it does include carbon footprint, and beyond that, it has potential to calculate 15 plus environmental impacts. So I always encourage for investment projects to request the life cycle assessment. Carbon footprint is not good enough. Based on the studies, the low carbon energy technologies that have the smallest footprint are nuclear, hydropower, wind, and solar. If we consider the material used without the water, we have pretty much the same situation. And the accounting for water, we have the hydropower that also comes into the list. And if we think of the complete total environmental impact, the small hydropower, the nuclear, and solar and wind becomes the most sustainable, I would say, in terms of the environmental sustainability. So that is it for today. And now please open your mics, and I would love to extend on any part that you have seen. And feel free to ask any questions. And okay, I have seen the question that I said I will answer later.
Oh.
I cannot find the question that was, okay. Oh yeah, my question was covered, okay. Someone wanted to turn on the mic, maybe I will switch off my mic.
Oh, we can't hear you.
Thank you. So the question is, do you see much of a role for natural gas in the transition to green energy? For me, it depends on the source of the natural gas. If it is as a byproduct from other processes and it is from waste to energy, is amazing. But when we just create biogas for the sake of an energy, I think it's not the best, because it is very fast transition to release also the carbon dioxide and other greenhouse gases. So from when it is from the waste to energy, I think it is great opportunity. And in terms of the circular economy, if any waste can help us create energy, I think that is a great transition.
Okay, thank you.
And
Thank
so
you.
for the burning, agricultural runoff and stuff to make biogas, natural gas, is there any way to purify like afterwards? You said it burns, creates a lot of CO2. Is there any way to kind of like, I don't know if my question makes sense.
Well, honestly, as far as I understand the process, it always creates the CO2, unless we put the carbon capture system there.
Yeah, so you can get a carbon capture. Okay, yeah, that's kind of what I meant. Yeah.
Yeah. Yes. What are the dangers of nuclear energy? It's a very interesting question. Let me say, actually, I have some slides on nuclear energy, and I was hoping you will ask. So before maybe showing you extra slides, I can read the other question. What are your thoughts on the nuclear fusion energy? Oh, I think it's an amazing development, and I believe we will see it in the near future. And ideally, we won't have to deal with the nuclear waste anymore. Based on what we are dealing right now, it's already very well kept, I would say. And surprisingly, the nuclear energy actually takes much more responsibility for the waste storage rather than any other low carbon energies like solars or wind. They don't have actually the system to prevent the hazardous waste that it is to contaminate the environment. Because I guess it's new, or I don't know why there are no such like regulations. There are some, but it's of course less strict than for nuclear. Because of the bad reputation, nuclear has the highest safety standards. And by amount of waste it is producing and by the safety that is called the multi-layer safety, if it is high level waste, it's impossible to get contamination from the proper nuclear waste storage. Of course, there are different, I already started answering the previous question, but it's my favorite topic. Based on the type of the nuclear waste, it can be a low-level waste, it can be intermediate level waste, and it can be high-level waste. What is normally we are feared of in media is the high-level waste, that is the spent fuel. And no ever in life you can come across of the spent fuel because it's taken care so well. I was lucky once. I was in Canada at the spent fuel waste storage as a environmental audit, and I was surprised how well it preserved. Ideally, in the future, it will be posted underground under this multi-layer concept as a natural layer, as a granite, for example, rock, and then the other engineered barriers, that it will be impossible to pose any contamination. But nowadays, it's not allowed underground disposal because of the public resistance. So nowadays, what is done, it's the all nuclear waste is being stored in the facilities just on the land, which is actually much more potentially hazardous rather than if we put them down. But anyway, right now they're stored in these large facilities, and each container has also multi-layer security that is filled with helium gas. Why helium gas? Because if you remember the periodic table, helium is the second element, which means it has the smallest radius of the molecules. It means if there is any leakage from the container, that the helium detector will detect it immediately. But the containers are built so perfectly that even the smallest molecules cannot leak through it. Not speaking about like large radioactive elements, which are much, much larger by radius. So helium detection guarantees that there is no leakage, and multi-barrier system works. So this is about the waste. And speaking about the fusion, ideally we will mitigate any high-level waste, because the intermediate level waste, it will still be present. It contains all of the materials that were in the reactor room. So it's there. Yeah, it could be membranes, for example, from some of the filtering systems, or some materials that have some contamination. They called intermediate. And low-level waste is basically everything almost from the nuclear power plant. So there are different categories, and if the fusion will be feasible, it will solve the problem of the high-level waste. All right, let me see if I can show you the slides on the nuclear.
Can I just ask something about this? Because my boyfriend is studying like engineering, and he's a lot into nuclear powers and so on. And if I remember correctly, he mentioned that the new generation nuclear plants, like the fourth one, I think, they're able to reuse the nuclear waste to produce new energy. Is that correct, or?
It exists only in Russia and France, because it is a joint research project for, I think, already 25 or 30 years. And it's true, in Russia, it's already exists the a system of where one type, when I was telling to you that nuclear has different types of reactors and different types of fuels, this is exactly this story. Because not all the fuel can be recycled and not all fuel can be used to run the reactor. So what they did, they actually found out how to use the waste of one type of reactor to enrich it and to use it for the other type of the reactor. So it's not used as it is, like as a brand new, but it completely uses from a different type reactor. But since all of this is nuclear, it's a fission, and then it creates the closed cycle of the fuel, which is amazing. It doesn't solve all the nuclear waste, no. It's a very specific two types of reactors. But if we create more these specific types of reactors, it solves a big problem. So it's actually really great. There is a scientific article written, and it shows the closed fuel cycle advantages. And it's amazing because it's already been in operation more than 10 years. Yes, thank you for asking. Okay. We'll see what we have for nuclear. If we don't have, would you categorize Fukushima crisis as part of the nuclear risks? Well, of course, there are these kind of risks, and my slides will answer this question. I will open them right now. Are there any solar energy forms that don't need rare earth materials? Well, yeah, I'm sure there are different types of photovoltaic systems. Some of them, well, all of them are based on the silicon, but some of them thin silicon, some of them mono, multicrystalline. About the rare earth materials, I think there are some designs should be without them. It's just, I don't know all of the technologies, but again, I'm sure there are. Yeah. Okay, let me show you the slides for, we have still 20 minutes more, so I think it's perfect timing. This is not. Okay, just a second. Before I can share you the slides. I'll just tell you that I became environmentalist myself because of the nuclear, because because I was born by the Nuclear Institute in Russia, where my whole family worked at the research institute with 5 different types of reactors. And the entire city is concerned that it's not healthy, the river is not healthy, the soil is poison, and no one really knows the data. So it was my personal motivation to choose the topic of nuclear to find out personally what's going on. And that became my diploma thesis in Moscow. And then when I went to France, my PhD was under the French Nuclear Waste Management Organization, ANDRA. So I did laboratory research. And then in Canada, I became the environmental audit. And right now, even though I don't work for environmental consultancy with respect to nuclear, I believe that nuclear has a great potential in the transition of energy. All right, I see that some people are leaving. I hope some still stay. Okay. All right. So the nuclear power, of course, there are different types, and most of what we know is the large conventional reactors. And recently it becomes more popular, like small modular reactors. Some of them can even be built underground, and one small modular reactor can create energy enough for a small eco-village, let's say. And these small modular reactors, they don't require much maintenance. And there is microreactors that are used, for example, in the submarines. So there are different reactors, and again, as in any kind of energy, try to avoid generalization because there are different types of fuel and waste. Just some information on the footprint of the like how efficient is energy production by different renewables. And on the left, you can see the green dot on the map. If it is all the existing, the solar and nuclear would be combined, how much land would it take? It is represented by the green dot. And by 2050, if all the energy transit to nuclear, it would take actually the smaller place. But if by 2050 all the energy will be replaced by renewables, it will take much more, just the land space as demonstrated by the red color. So it's about the land footprint. What about the concerns from Chernobyl and from Fukushima that are the most famous events, unfortunately, that happened in this industry? From Chernobyl, United Nations, after 30 years, says that actually confirmed death was only 15 deaths from the thyroid cancer and 28 from acute radiation, which was by those people who actually were, they called evacuators, who were actually cleaning the reactor zone. And in general, it's considered that the death rate was only 1% of what was actually predicted. So predicted it was 16,000 deaths, and it turned out to be 160. There is no effect on fertility or malformations that were observed after, and no increase in any other cancer, including liquidators. So this data could be surprising because, again, what we hear in the media is much more drastic events that happened after the Chernobyl. And here, unfortunately, I don't have this slide, but you may find in National Geographic, and I think there are 2 more movies about Chernobyl. Please watch them because it shows how the land actually thrives and biodiversity is increasing after the Chernobyl accident because the humans left the land. So it turns out that our cities are more detrimental than the explosion of the nuclear reactor. With Fukushima, also the United Nations says that there were actually no radiation-related deaths, but there was a lot of death. About 1,500 people died due to the evacuation. That was very stressful, and about 20,000 people died in tsunami itself. A lot of discussions were about the evacuation, that it was performed not actually the way it was supposed to be performed, so that there was some physiological harm due to actually evacuation and also radiophobia. And this is what we call when, well, actually, you know, right? When we think we have to present in public, the stomach starts aching. So the radiophobia is kind of similar when it is over-transmitted, the effect of radiation. It can cause some physiological damage. And actually what was surprising that the damage was actually caused not because of the accident itself, but by the procedures that were taken after it. So what happened? Yeah, what happened, I will tell you in a second. Here is a comparison of public perception of radiation. That this professor, she asked, she went into the street and made an interview and was asking people, how do you think, how many people died in Chernobyl accident due to radiation and in Fukushima? And most of the people answered that it was thousands or above 1 million of death. Only tens people answered that it was about 1 to 2%, and none of them answered that it was 0%, which is true for Fukushima, whereas 8% is true for Chernobyl. Speaking about the ionizing radiation, of course, we live on the planet Earth that is in the space, and most of the radiation comes from the space or from the ground. So from the space, it comes 12%, and from the natural ground, it comes 84%. 9% comes from the food, and a lot of radiation comes from the buildings. That's why it's really good to open your windows, because in the construction materials, there could be some gamma radiation. But surprisingly, that artificial radiation that is we are exposed to causing about 16% of our exposure. And it has medical, of course, medical treatments of cancer or the stomatology, and some of the artificial like nuclear discharges or fallouts or so forth. And this professor, she decided to take her students and to fly from Paris to Fukushima. And she decided to put a Gauss meter, not Gauss meter, dosimeter that is measuring the microsieverts per hour. It's a radiation, and she put them onto every student. So when they went through the security in the airport in Paris, they had the peak of the radiation that you can see. It's a security. So every time when we go through the security frames, we are exposed to radiation. And then when we fly on the airplanes, we're actually closer to the space, which is highly radioactive. So it's the peak was so high that she had to cut the graph, otherwise it would be not seeing the other peaks. That's why the airplane pilots, and they retired earlier than others because of this radiation exposure. Then with the students, they arrived to Tokyo and they came to the French embassy, and again they went to the security frame and they were exposed, and then they actually went to Fukushima. And well, relatively, it's hard to say, but you can see that there was some higher level of radiation, but still it was not probably causing environmental health concerns. This is a comparison of the different exposure from the dental X-ray, which is less harmful, to the chest X-ray, to the radiotherapy for breast cancer. And the Chernobyl is basically 5 times, not 5 times, it's millisieverts, and this is sieverts, so it's a 1 order of magnitude less for the residents of the who were evacuated. So also in this National Geographic movie, they discussed that probably the evacuation of the Chernobyl was not necessary, that again, the evacuation caused more harm than the exposure itself. Oh yeah, that's the place that I visited in Canada. That's how it looks now, the storage of high level spent fuel. And that is very well preserved. You can walk next to it and you have the dosimeter on your neck. And because of it detects helium leaks, you can immediately be notified if there is a lack of encapsulation. And when I was talking to you about the multi-barrier concept, it's demonstrated on the right side. So ideally in the future, what is proposed is to relocate those containers in the underground, where first the safety barrier is the natural rock, which should be non-permeable, for example, granite. Then the second layer is some bentonite or clay, and then the canisters that are made from non-corrosive steel and copper. Interesting question. Do you think it will be possible to use radiation-eating fungi for nuclear waste management? It's a great question. Actually, it makes sense. I don't know how feasible, how scalable it is. But when I did my PhD in Canada, I worked with bacteria, which is just natural bacteria. It's from the lake that can eat uranium and get energy from it. And by eating uranium, it actually detoxifies and makes it non-radioactive. So from the fundamental science, yes, it's possible. How scalable it is, it's a question. This is exactly about the question that was about the recycling the nuclear waste. So normally on the left side is a normal fuel cycle where the, for example, uranium ore is mined from the core, then it's enriched with a higher concentration of uranium, then it's used to create the fuel, and then the fuel is supplied to the power plant to produce electricity. Then after the spent fuel, it goes to the cooling swimming pools because water, again, is the best carrier of energy. It's the best protection. And after 10 years of the cooling and just natural radioactive decay, the radiation level is good enough to be stored. Either right now it's stored in the storage facilities, and in the future it's planned to be in the underground disposal. But what is now becoming feasible is this French-Russian collaboration project, when the fuel from one reactor is actually reprocessed to use the MOX fuel. So it's another type of fuel that is possible to use in the reactor. Here on the image, it's a little bit simplified, that it shows that it goes to the same reactor. As far as I remember, it doesn't go to the same reactor, it goes to a different reactor. But I think it was demonstrated here for simplification that actually, yes, it's possible to close the fuel cycle. These are the results of the life cycle assessment of the what resources are mainly used at different life cycle. And yes, water consumption is one of the big water uses. And the water pollution is normally not during the operation of the reactors, which is blue, but during the mining of uranium oil. So it's basically your mining is causing the water pollution rather than reactor use. Well, we won't go into these details, but you can also, if you're interested, it's a life cycle assessment details comparison for the coal, oil and gas, photovoltaics, hydro, wind, and nuclear, different environmental factors. And we can see that nuclear is a green color. For example, in the water withdrawal, it's quite significant, again, for the cooling system, but in the other, let's say, for the greenhouse gases, it's the smallest. So this is a good actually overview to see what environmental impact is more relative with the context to the project. These are some citations that I can agree with, that nowadays, have you heard about the carbon, what it's called, carbon footprint? We have the scope 1, 2, and 3. And right now there are discussions about the scope 4, which could be the mitigated carbon footprint. And in this sense, the nuclear is actually named as a saving 1.8 million lives today by preventing the burning of fossil fuels. So this would be the scope 4, if they accept the scope 4 for the carbon footprint. And the other citation is the anti-nuclear movement, to which I once belonged, has misled the world about the impacts of radiation on human health. Well, these are some videos to watch when you have free time. They're by Michael Schellenberger, and he has a company, environmental, I don't remember the name of the company, but I was talking to Michael personally, and he actually played a significant role in my understanding of the role of the nuclear in the energy transition. So you can watch it at home. Yeah, this is about the small modular reactor as compared to the typical pressurized water reactors. The major difference is their size is very compact. The construction is faster. Normal construction takes up to 10 years. This takes up to 5 years. The emergency area is smaller because of the less fuel. So it, instead of 16 kilometers radius of emergency, is 2 kilometers radius. It is less capital cost and reduced waste. Again, here is the message to always keep eyes open on the innovations, because all of the energy types are being developed. This is the life cycle of the small modular reactors. And then the hydrogen energy. Well, that's the end, I guess, for the nuclear. If you have questions here, and if I asked your question, I saw one question about the tritium. What about the issue of tritium with the development of fusion energy in regards to how rare it is and expensive to produce? It's a very sophisticated question. I'm not sure that I'm qualified enough, but my guess is that we are now able to produce hydrogen, and tritium is an isotope of hydrogen. And actually, tritium is very well known in Canada. So all the Canadian CANDU reactors, they run on the tritium water. So I believe it will be possible to produce it even more. And about expense, I think, as always, as the technology develops, it becomes less expensive. So I think it could be possibly a good source. If you have any more questions on what you have seen, what would you suggest someone as the best way to power their own house or a small farm, for example, 100% with green energy? That's best concluding question. Thank you so much. As a takeaway from this class, never generalize. Where is this house? What climate? What public? How far is it from the grid? What is available? What is the speed? What is, I would say it is, there is no simple answer, and probably there wouldn't be just one type of energy. It would be probably, my option would be to buy a wind turbine from my friend, because I know that it can run at any kind of climate conditions. But if I have a river nearby, maybe I will install a small water turbine that wouldn't dam the river, but will create some also part. And it really depends on the landscape. Maybe I will also look what is needed to help the natural ecosystem, because right now there are projects that are called nature-based solutions. And for example, hydropower can be used to support the biodiversity. So if we create the hydropower, not like large damming the rivers, but the small derivative systems, we can create small wetlands. Wetlands filtrate the water, they increase the water quality, they create the habitat for aqueous and also terrestrial species. And this is one of the projects I'm working right now as a nano hydropower, as a nature-based solution to maintain the biodiversity of small forest in Slovenia. So I would also always say it depends on the goal. What is your goal? And on what are the local conditions? And I'm sure there are always solutions to meet our goals. Thank you for this excellent, I would say, closing question. And by this, I would like thank everyone for your attention. I hope you took some useful takeaway messages that you can apply when consider what you can recommend as a strategy for business projects, for companies, to diversify and to specify. All right. Thank you, everyone.
Thank you very much.
Thank you.
Thank you very much.
Bye.
Thank you.
Thank you.